In this video, we're going to prove that the negative of a is equal to a, and that negative a is equal to minus 1 times a. Another way of stating that more formally is that we're going to prove first that the additive inverse of a is equal to a, and that the additive inverse of a can be obtained by multiplying a by negative 1. So we're really going to prove 4 different propositions. The first being that the additive inverse of a is equal to a for any integer a. The second being that if a is an integer, the additive inverse of a is obtained by multiplying a by negative 1. The third, if a and b are integers, then the additive inverse of the sum is the sum of the additive inverses. And the fourth, if a and b are integers, then the additive inverse of the product a times b is the additive inverse of a times b, or a times the additive inverse of b. So let's prove the first proposition. So let a be an integer, then we claim that the additive inverse of a is equal to a. Now remember that when we say that negative a is the additive inverse of a, what we mean is that a plus negative a is equal to negative a plus a is equal to 0. Okay, so the condition of being an additive inverse is that a certain addition equation is true. But we can look at this addition equation in another way, as saying that what is the additive inverse of negative a? Well, according to this same equation, the additive inverse of negative a is a. Okay, and if a is the additive inverse of negative a, how do we denote the additive inverse of negative a? It's negative of negative a. And since additive inverses are unique, we can write the negative of a is equal to a. In other words, the additive inverse of a is equal to a. So now let's prove our second proposition. If a is an integer, then the additive inverse of a is negative 1 times a. So let a be an integer, and let's consider a plus negative 1 times a. If negative 1 times a really is the additive inverse of a, that should equal 0. Well, a plus negative 1 times a is going to be 1 times a plus negative 1 times a. We can use the distributive property to factor out the a. So this becomes 1 plus the additive inverse of 1 plus negative 1 times a. 1 plus the additive inverse of 1 is 0, so that becomes 0 times a. And then by our previous proposition, by the previous video, we know that 0 times anything is 0, so a plus negative 1 times a is 0. And that exactly means that negative 1 times a has to be the additive inverse of a. Okay? So negative 1 times a is the additive inverse of a according to that addition equation that it satisfies. So that means that minus a is equal to negative 1 times a. Now we'll use the previous proposition to prove that if a and b are integers, then the additive inverse of the sum is the sum of the additive inverses. Let a and b be integers. We know from the previous proposition that we can obtain the additive inverse of any integer by multiplying the integer by negative 1, so the additive inverse of the sum of a and b is negative 1 times the sum of a and b. Using the distributive property then, we can take that equation, distribute through the negative 1, and we see that the additive inverse of a plus b is minus 1 times a plus minus 1 times b. Using again that previous proposition, we know minus 1 times a is the additive inverse of a. We know minus 1 times b is the additive inverse of b. And we've proven then that the additive inverse of the sum of a and b is the sum of the additive inverses of a and b. So finally, let's look at the proposition that if a and b are integers, then the additive inverse of the product of a and b is either the additive inverse of a times b or a times the additive inverse of b. Let a and b be integers. Again, from the previous proposition, we know that we can obtain the additive inverse of any integer by multiplying that integer by negative 1. So the additive inverse of the product of a and b is going to be minus 1 times the product of a and b. So we can use associativity to multiply negative 1 times a, And we know, again, from previous that negative 1 times a is the additive inverse of a. So this becomes the additive inverse of the product of a and b is the additive inverse of a times b. Okay, the other one's very similar. Again, the additive inverse of the product of a and b is negative 1 times the product of a and b. We can use commutativity and associativity of multiplication to rearrange that and do the product of negative 1 and b first. The product of negative 1 and b, of course, is going to be the additive inverse of b. So, again, the additive inverse of the product of a and b can be viewed as a times the additive inverse of b. And that completes this video. Thanks for listening.